Alrighty, welcome back to the C++ course. This week we're going to be taking a look at Chapter 5, all about looping structures, or how to repeat certain sections of your code one or more times. Here's our list of topics for the day. We're going to talk about the while loop, and that's going to introduce us to the topic of looping in general. We'll take a look at how to use while loops for input validation. And in the previous couple chapters, we've been trying to do input validation, but really to do it properly, to do it more than once. To basically keep prompting for the user to enter valid data, we've needed some notion of a loop for a while now. We need to take a look at the increment and decrement operators. These are used a lot when you're looping, so this idea of quickly adding one or subtracting one from a variable. And that gets into the idea of 5.4 here, or counters. We're going to look at how we keep a running total and how that helps us get out of our looping structures. We'll take a look at this guy, fancy sounding word. It's called a sentinel. Another type of loop called the do-while loop, the for loop, and deciding which loop to use. So we've really mentioned three of them, the while, the do-while, and the for. They can all do basically any kind of looping that you may need, but certain loops definitely lend themselves better to certain situations. So we'll kind of analyze a few use cases for when one would be more appropriate over the other. And I definitely have my opinions. Just having worked professionally writing code for a while now, I definitely kind of have a feel for which ones you see out in the wild more than other ones. There is an idea of nested loops. So in the previous chapter, we talked about nested if statements. So we can place loops inside of other loops. We'll look at how to break out of a loop early before the condition for the loop body terminates. Kind of some random point here, using files for data storage. I guess that kind of fits in with this idea of looping, because what this is we're going to have some kind of text file or a data file that's going to contain some kind of information or content that we want to read into our programs. And to read that in effectively and efficiently, we need to use a loop to loop over the content of our files. And then as a final point, we'll take a brief look at how to create good test data. Testing your programs is like an entire semester's worth of coursework. There are formal ways to do testing and informal ways. We're just going to scratch the surface here in this last point. Okay, by way of introduction to loops, the while loop, probably the most widely known type of loop. It exists in virtually all programming languages, C++, no exception. So generally speaking, what is a loop? It's a part of a program that executes more than one times, i.e. it repeats. Here is the general syntax of a while loop. And the good thing is this piece in the parentheses here, this condition, we talked a lot about that in the last chapter, and almost entirely, chapter 4 was almost entirely based on this guy in the parentheses, conditions. So we're still going to be using conditions with looping structures. Just like in our if statements, the condition tells us when we're going to actually execute the body of the if statement. And in terms of looping, our condition is going to tell us when we're going to execute the body of the loop. So we have the keyword while, then we have our condition. In our curly braces opening and closing, we have one or more statements that we're going to run, as long as the condition in the while loop is true. So as long as that condition is met, we will execute the statements in the body of the while. Just like with our if statements, you can omit the opening and closing curly brace if there's only one statement in the body of the loop. Though my recommendation for this still stands, I would say don't worry about remembering if you can include them or not. I would say just always include the curly braces. It's just one less thing to have to remember, though I will show you what it looks like with them omitted, just in case you encounter that sort of thing in the wild. So here's our general format structure of syntax for the while loop. So how does it work? You've seen what it looks like. How does it work? So condition is evaluated. So when we enter into a loop, every loop has a condition. It's just a matter of where it's placed and kind of what it looks like syntactically. But All while loops need a condition to determine if they should execute. So the condition inside the parens is evaluated. If it is true, just like with our if statements, if the while condition is true, the statements inside of the curly braces are executed, and then the condition is evaluated again. So check the condition, is this true or false? If it is true, execute these statements, then jump back up to the top and check the condition again. If it's true again, execute the statements. If it is false, the loop is exited and normal program flow continues sort of after this closing curly brace. Okay, so you might be thinking like, okay, great, if the condition is true, we're going to execute these statements, but obviously we need a way to make it false. Otherwise, we're going to be dealing with the infamous infinite loop. And we're going to talk about infinite loops later in the chapter. I will give you a little preview and say, yes, most of the time infinite loops are bad and will cause your programs to crash. However, there are times in very specialized and structured situations, such as game programming, video game programming, where while loops can be valuable or infinite while loops can be valuable and in fact intentional. And they're the only way to achieve what we need to do in game programming. I'll give you some more details and example of that when we get there. Oh, and just by way of terminology, an iteration is an execution of the loop body. So if I say the word iteration, I simply mean we've checked to make sure a condition is true, and we've executed the statements in the curly braces one time. One iteration. If you're into flowcharts, which I know our textbook loves, here's an example of the while loop flow of control. So just like our if statement, we have a diamond here, a diamond shape in our flowchart that represents a condition. The condition is checked. If the condition evaluates to false, notice what we're doing here. We're skipping over the statements of the while loop body. If it is true, we execute the statements. Control is returned back up here, the condition. The condition is checked again. If true, execute the statements. If false, continue on as normal. Here's an actual C++ example of a while loop. So we have an integer called val equal to 5. Here's our while loop. Here's our reserved keyword, C++ reserved keyword, while. We have our parens here, meaning that we're dealing with a condition. Notice, by the way, there's no semicolon after the condition of our while loop. There is, one of our looping structures does make use of semicolons in strange places, I would say, but the while loop is not one of them. You do not need the semicolon there after the condition of the while loop. And so what is our condition? Well, we're checking to see if this variable called val, which we declared and initialized up here, is that greater than or equal to 0. If it is, iterate through the while loop. If it is, basically our statements here print out the value of val followed by 2 spaces. So that's our cout statement, followed by this key piece right here. Val equals val minus 1. So the first time this condition is checked, we're checking the contents of val and seeing if it's greater than or equal to 0. So it definitely is. We initialized it to 5, so yes, that is greater than or equal to 0. We execute this cout statement, then we execute this assignment statement. So we say val, we need to update the value of val. So we're going to say val equals val minus 1. Now, we've finished with our statements, so we return back to the top of the while loop. Check the condition again. So now val is equal to 4. Yes, 4 is greater than or equal to 0, so execute the loop body again. Update val, keep updating val until val becomes 0. Jump back up here. Is 0 greater than or equal to 0? Yes, it is. So go and execute the body of the while loop. Update val, so now 0 equals 0 minus 1. Val is now negative 1. We jump back up to the while condition. Negative 1 is not greater than or equal to 0, so we're done executing this while loop, and program flow continues. This would be the output of our cout statements, so it's just printing out what val is each iteration. 5, 4, 3, 2, 1, 0. And val is called the loop control variable. without val, without this variable, we would have an infinite loop. And it's very common for students to forget to students, what am I talking about? It's common for me to do this too. Professional programmers forget to do this. To do something like this. Now, val is always equal to 5 and never updated. So what we've just done here is introduced an infinite loop. Because we've set val equal to 5, 5 is always greater than or equal to 0, and we're just going to keep printing out 5 forever until our computers run out of memory and our program crashes. There we go. There are easier and I would say better ways than this to sort of work with your control variable, and we'll talk about those as we move through. First though, let's jump into a hands-on on page 248. Again, this is chapter 5. Let us create a new project. Console app EX5-1. Visual Studio just freaked out on me. Let's reboot. Okay, create new project. Console app EX5-1. Solution name is Chapter 5. Cool. Get some practice here. Let me resize my windows. Using the standard namespace. Okay, let's declare and initialize an int variable called count. Set it equal to 1. While, there's our keyword while, followed by our conditional. Count is less than or equal to 5. No semicolon here, but an open and closing curly brace. We'll see out just some random statement, hello. We'll set count equal to count plus 1. Now there's the obvious question here, so like, okay, do I want to increase until I get to 5, or do I want to subtract until I get to 0? So in this case, we're adding. Let me pull up that example again. Yeah, you can do it either way. So here we're initializing val to 5 and checking to see if it's greater than or equal to 0 and subtracting 1 each time. In Visual Studio, we're kind of doing the opposite. We're setting it equal to 1, and then we're checking sort of the upper limit of it. And when we're done iterating, we'll see out. That's all, folks. And return. Cool. Oh, see out. Here we go. Count equals count plus 1. All right, let's run it. Hopefully you can guess what's going to be printed before I actually do run it. Hello, 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 hello. That's all, folks. So count is equal to 1. 1 is less than or equal to 5. Print out hello. Add 1 to count. Count is now 2. 2 is less than or equal to 5. Do it again and again until we increment 1 to count. Now count is 5. 5 is less than or equal to 5, so do it again. Count becomes 6. 6 is not less than or equal to 5. The loop exits and the program terminates. Pretty straightforward. Most programming languages handle looping structures in a very, very similar syntax. All right. Some words on the while loop. The while loop is a pre-test loop. Pre-test, the condition is evaluated before the loop executes. So if the condition is initially false, the statements in the body of the loop are never executed. If the condition is initially true, the statements in the body will continue to execute until the condition becomes false. There's this version of looping, and then we're going to see another example called the do while loop. which is, I guess, like a post-test. So pre-test, just remember, with a while loop, since it is pre-test, it is conceivable, it's possible that the body of the loop may never execute. If the condition, like the point says here, if the condition is initially false, the statements of the loop body will never be run. Exiting the loop, so the loop must contain code to allow the condition to eventually become false so the loop can be exited. Otherwise, you have an infinite loop, or in other words, a loop that does not stop. Here's an example. Hopefully you can guess what the problem is here. They set x equal to 5. 5 is greater than 0, has been since the beginning of time. Print out 5, but never actually modify x. So this thing keeps running because, again, 5 is greater than 0 and always will be, at least until our computers run out of memory. So let me explain a little more detail why an infinite loop might actually be a good thing. If you think about the general execution of a video game, any game you may play has something that's known as the main game loop. And essentially what this is the main game loop says while true, meaning just keep looping and process your gameplay. And only when some usually player-triggered action happens, the loop will be forced to terminate. So for example, if the player hits escape and then quit game, that would force the while loop to quit and terminate early. Now we haven't seen an example of that yet. There are ways to force a loop to exit before the condition becomes false. And that's certainly an example in terms of video games. So keep doing your main game loop until the player tells it to stop, or the player runs out of health, or some other game event happens that would force that main game loop to either pause or just give up and terminate entirely. Another example of like an infinite loop could be when you're validating user input. So if you're prompting the user for some kind of input and they just keep getting it wrong, the user, gosh darn it, is just so inept at using computers that they keep entering invalid data. We're asking for an integer and they keep giving us a char. So we have to keep looping over and over again until the player gives us valid input. Potentially, if we have a really troubled or challenged user, that could potentially be an infinite loop. Here's some more loop errors, which I mentioned earlier. Don't put a semicolon immediately after the condition. Don't forget the curlies. This is valid C++ code because if you remember earlier, we said if I omit the curly braces, this is fine. C++ will consider this to be the entire while loop structure with one statement. Just because we've indented it here doesn't make it a part of the while loop. There are certain languages like Python where the indentation alone would make it part of the looping body, but C++ is not one of them. So C++, to have both of these statements included in the body of the while loop, you need to surround them with curly braces. Though, like I said, this would be valid C++ code. This would compile and would run. You would just get some strange runtime issues. Don't use single equals when you meant to use double equal sign. So we talked about this last chapter. Remember, this is valid C++ code. Find the error, basically. This guy right here. This is always true. This again is valid C++ code. This is always true. Num entries equals 3. That's an assignment statement. And the result of an assignment statement behind the scenes, C++ treats this as meaning true. So this is going to keep executing over and over again. Okay, so don't use a single equal sign when you mean to use double equal sign. This will compile. While loop programming style, so loop body statements should be indented, just like with our if statements. Align the curly braces with the loop header and place them on lines by themselves. Yeah, that's what we'll do. There are some languages and some, I guess, styles that would place the opening curly on the same line as the condition. It says, note, the conventions above make the source code more understandable by someone who's reading it. They have no effect on how the code compiles or the program executes. A matter of personal and professional style. And a lot of times you don't have any control over that. So if you're working on a larger team and the entire team puts this opening curly on the same line as the condition of your loops and if statements, you better do that too. Let's check it out hands-on on page 252. All right. Get up here. Set as startup project. Okay, program uses a loop to compute letter grades for multiple students. So let's use standard namespace. We're going to create a bunch of named constants. So const int min a score equals 90. They're kind of formatting them nicely like this. Min b score equals 80. Min c score equals 70. Finally, min possible score equals 0. Okay, that's our constants, so let's create some variables. Int num students, current student, and the test score, all integers. Char grade, bool good score equals true. Let's prompt the user, cout, how many students do you have grades for? Cn num students. Cool. Initialize, that's in a comment. So student equals 1. So that's like the current student that we're working with or focused on. That's basically our loop counter. Let me comment that actually and say this is basically functions as our loop counter. It's not common to see a loop counter named this way. Usually loop counters are called count, or even more commonly I or j. But we'll go with it. Say while student is less than or equal to num students. Let's do stuff. So let's see out. Enter the numeric test score for student number. And we'll see out student, followed by a colon and a space. We're going to use this comma syntax. And then right away cin test score. So every iteration of the loop, we're actually executing a cin statement. We've got a cin statement in the body of the while loop. Okay, then we're going to do our testing, and I believe we saw an example of this last chapter. So if test score is greater than or equal to min a score, grade equals a. You can see my single line if statement body here, just saving some space. Feel free to wrap that in curly braces if you're more comfortable with that sort of syntax. So if test score is greater than or equal to min b score, grade equals b. If test score greater than or equal to min c score, grade equals c. And we need else ifs here. That would have been a horrible, horrible logic error. Else if. Remember, if I just left these as if statements, they would execute one after another. So all of these would get checked because they're else ifs, if one of these becomes true, then the entire else if structure exits. Otherwise, all of the if conditions would have been checked. I would have gotten some strange results. If test score is greater than or equal to min D score, grade equals D, and we're just doing else if test score greater than equal to min possible score, good score equals false. This is subjective, I suppose. Good score equals false. A better name for this variable probably would be valid score. Like when I saw good score, I assumed they meant, hey, did you get a good score? Was your score really good? But it's more like a valid score. So if the test score was, less than 0, I would call it like invalid, not a not good score. Fine. If good score, or as we were saying, valid score, C out letter grade followed by a new line, else score can't be below 0. Now, critically here, student equals student plus 1, which will help us exit the while loop when that condition becomes false. So how many students? Oh, what does the book have? 3. Let's make sure our input and output match the book's. 88, letter grade B. 70, this would be student number 2, letter grade C. Student number 3 gets a 93, letter grade A, and the program exits. Let's take a look at how to use the while loop for input validation. So loops are an appropriate structure for validating user input because we're going to keep on prompting the user until they give us something we can work with and process. So we prompt for and read the data. We use a while loop to test if the data is valid. We enter the loop only if the data is not valid. And the loop body display an error message and prompt the user to re-enter the data. The loop will not be exited until the user enters valid data. So in this case, we're kind of treating the loop as sort of like a gatekeeper to the actual processing of the input. So an example here, enter number 1 through 100 and I will guess it. C in the number. So while the number is less than 1, we've said it needs to be between 1 and 100. While it's less than 1 or it's greater than 100, we're basically treating that as invalid input and we're reprompting for input. So we say the number must be between 1 and 100, re-enter your number and prompt for the number, C in the number. So this is going to keep happening until this condition becomes true. Sorry, becomes false. It's a little bit tricky. When this thing becomes false, the body of the while loop will not execute, and then we can assume we have valid input and continue on with the execution of the program. Let's take a look at hands-on, page 255. Five, 3. $550 or $256, I guess. Okay. Const int min players equals 9, max players equals 15. Those are our constants. Let's create some variables. So int players, team size, num teams, and left over. See out. how many players per team. Cout, enter a value in the range. We're going to get real comfortable with variable substitution and cout statements here. So we're still in the same cout. Notice I did not put a semicolon there, just to try to keep things readable on the same screen here. I'm asking the user to enter a range. I'm going to use my double angle brackets, printing out the value of the constant min players, printing out a hyphen, printing out the value of max players. Now I have to close up my paren. I got to use that angle bracket still. Colon. Yeah, it's kind of messy. Semicolon, and then finally we can see in team size. Now we're going to validate user input while team size is less than min players, or team size is greater than max players. So if one of those is true, remember, because we're using or, if one of those is true, we're going to execute the body of the while loop and say cout team size should be right. Next line, cout min players to max players label players. New line. Now we're going to prompt again, cout how many players per team, question mark, cin team size. And we're going to keep doing that until they give us a valid input. Now we're going to cout how many players are available. Cn players. And we're going to say while players is less than or equal to 0. Cout. Please enter a number greater than 0. Cn players. Okay, so we basically have two gates that the user has to get through to assure us that they have entered valid inputs. So they have to enter a team size that's less than min players, between min players and max players. Once they have done that, then they have to enter a value of players, which is greater than 0. Can't be equal to 0, otherwise we'll throw this error at them. It has to be greater than 0. Once they pass through this gate, then we can assume that they've entered valid input and just crunch some numbers here. So num teams equals players divided by team size. We're going to mod on the next line. Left over equals players mod team size. Remember, that gets us a remainder after a division, and we'll just display the results. So cout there will be num teams with left over players left. New line, return 0. Let's see how we do here. All right, following the input of the textbook, how many players do we wish per team? Let's try 8. Nope, won't let us through. Let's try greater than 15. Let's try 16. Nope, won't let us through. Let's try 4. Nope. Okay, cool. So how many players are available? Let's use a large number. And we'll assume that division is correct. Now, in order to do what's known as code coverage, there's this big idea in computer programming called code coverage. And the goal of code coverage is to make sure that all of your code executes at least once when you're testing it. So we did a pretty good job there. We tested to make sure the team size, we ran the test case when team size was less than min players and greater than max, just to make sure that both those conditions worked. We did not, however, check this condition of the while loop to make sure that this gate worked. So we'll do 10 players to be in that range. Now, how many players are available? Let's try -1. Nope. How about A? Good times. Clearly, there's more validation that needs to happen there, which reminds me, if your program ever gets into an infinite loop like that, your key to breaking out of it is either to hit the stop sign here in Visual Studio, stop button, or on your keyboard, if you can't get to the stop button, in the command prompt that's infinite looping, the Control-C key combination will break out of the execution of your program. Control-C. Okay. Some shorthand here. The increment and decrement operators. Increment increases the value in the variable by 1. Plus plus adds 1 to a variable. So val plus plus, that shorthand is the same as val equals val plus 1. By far in the professional world, this is what you'll see. You will not see val equals val plus 1. Because why do all that extra typing if you can just do val plus plus? Decrement reduces the value in the variable by 1, so minus minus subtracts 1 from a variable. Val minus minus is the same as val equals val minus 1. You can do it before prefix mode or after postfix. Most commonly you'll see after though. Plus plus as opposed to, so val plus plus instead of plus plus val. They kind of do the same thing, but not really. And I'm not sure if we're going to get into the nuances of what the differences are in this chapter. So for now, stick with postfix operators. Yes, we are. I see it coming in a slide. Let's check out it hands-on 258. Quick example of the increment and decrement operators. EX5-4. Int count equals 1 while count is less than some number like 6. Sure, why not? Cout count followed by a couple spaces. Count plus plus to increment. Reassign count to the number 5 while count is greater than 0. Print it. And then decrement it. Cout versus count. It's getting me. There we go. Can't we just use I and J like normal programmers? So return 0. Set as my startup project. We'll just see what it prints out. There's no prompting for input. Make sure it matches the book. 1, 2, 3, 4, 5. Good. 5, 4, 3, 2, 1. So you can see how to terminate a loop by counting up or by counting down quickly using the increment and decrement operators. So here's a note on prefix mode. So what we just did in that example was postfix, so val++. You put the plus before, it's again called prefix, so you're incrementing or decrementing the variable and then returning the value of the new variable. It's this returned new value of the variable that's used in any operations with the same statement. Here's an example of prefix. So we've got an int x and an int y, both assigned to 1. We say x equals plus plus y, so we increase y to 2, then 2 is assigned to x. So we're incrementing y by 1, then assigning it to x, and it displays 2. Same thing with subtracting. So we're decrementing y by 1. Y is decremented by 1, then 1 is assigned to x. And here's the result. So let's compare that with postfix. So the plus plus minus minus after. So it is this returned current value of the variable that's used in any other operations within the same statement. Here we go. So y++ is returned as a 1. 1 is assigned to x. Y is incremented to 2. Yeah, I'm going to skip over that example. This is really nuanced. I've never been, in my years of programming, I've never been caught up in whether to use prefix or postfix, so we're going to scoot right along here. Let's talk about counters. So a counter is a variable that is incremented or decremented each time a loop iterates. We've used them so far. In our examples so far, we've called them things like count, students, think team size. It can be used to control the execution of the loop, also known as a loop control variable, must be initialized before entering the loop. And you can increment or decrement it inside the loop or in the loop test itself, which is kind of interesting. You can modify your loop control variable in the loop test or the condition of the loop. That comes into play when we get into for loops. You can also let the user control the loop. So you can write your code so that the user input determines the loop repetition. It can be used when the program processes a list of items and the user knows the number of items. If the user is prompted before the loop is entered, the user input is used to control the number of repetitions. Here's an example. So we've got an int num and limit, table of squares. How high do we want this code to go? So we're going to input an integer called limit, and we're going to print out the squares up to limit. So while num is less than or equal to limit, this is another common name for a loop control variable, num. While that num is less than or equal to the limit, whatever the user entered, we're going to set some formatting, and we're going to print out num times num, and then increment num by 1. This is user controlled, which, yeah, it can be dangerous. If the user enters in an extremely large value, could have unpredictable results if you get that integer overflow like we talked about a couple lessons ago. Let's check out the hands-on on page 263. Seven, yes. All right, looks like we're also including IO manip. For some output controls. So int num, last num, and there's a bunch of prompting there. I'm just going to say cout, enter an integer between 2 and 10. Cn last num. Okay, we're doing some input validation here. That's good. While we've got some parens here, last num is less than 2, or last num is greater than 10. Cout. Please enter an int between 2 and 10. Cn last num. And they're going to print it out in a nice looking table. I'm not going to worry about that in the interest of time. I'm going to say num equals 1 while num is less than or equal to last num. I'm going to cout set width 4, followed by num, followed by set width 7, followed by the actual calculation num times num, followed by an end line, and then the all-important num++ to actually get us out of this loop. For code coverage, we're going to try the lower bound, going outside of that, and the upper bound. So 1 and 11 don't work. The textbook uses 3. Cool. So basically, we didn't format this like they had it, but they've got 2 columns here. First column is the number. The second column is that number's square. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Very good. Keeping a running total. So running total is an accumulated sum of numbers from iterations of a loop, and this is also known as an accumulator. It's a variable that holds the running total. So you've got to have some kind of variable that stores that data, that stores the running total that you're looping through. So here's a couple ints, sum and num. And sum is your accumulator. So while num is less than or equal to 10, sum equals sum plus num. Feels like a Dr. Seuss book. Num++. Then we're going to print out what the value of the running sum, or what the total is. Let's take a look at this hands-on 5.8. Maybe we truly just look at it. Let's do it. 5.8. Const int num days equals 5. Int day double daily sales total sales equals 0.0. So both of those variables are double, which makes sense. We're dealing with currency here. So sales is currency, so we're going to need that fractional piece. So day initialized to 1, while day is less than or equal to num days. Cout enter sales for day. Cout the number of the current day we're iterating over, followed by our prompt, which is a colon. Cn daily sales, and now we'll crunch some numbers. Notice how we're not validating this. You could go completely nuts validating your user input. And if this is a real world application that an actual company was relying on for valid sales statistics, yes, we would want to make sure that we're validating all user input as thoroughly as possible. Total sales equals total sales plus daily sales, and day plus plus. So we're just getting these sales for the current day and incrementing it, adding it to the total sales that we keep as a running sum. Day plus plus is going to get us out of that loop eventually when day becomes strictly greater than num days. Cout fixed from our IO manip and show point set precision to cout total sales. Do a little formatting here. $, end line. 5-8 set as active project. Okay, enter sales for day 1. So 505.50, 615, 20, 488.25, 553.10, 614.05. Total is 277.610, which does match the textbook. Excellent. Okay, another key term, sentinel. Sentinel is a value in a list of values that indicates the end of the list. And I think what we're going to get into, not quite yet actually. So it indicates the end of a list or the end of something. It is a special value that cannot be confused with a valid value. For example, -999 for a test score. You would never actually have that value for a test score, so if you saw this show up in a list of data, you could assume that this is acting as a sentinel, or basically the end of the list of valid data. Used to terminate input when the user may not know how many values will be entered. This is often useful for when we're reading in the contents of a file, as we will do later in this chapter. So say we have a text file or a data file that contains student scores. Maybe there's one score per line in the text file. And to let the program know that we've reached the end of the scores, the end of the list of scores, we have this strange looking score, -999, which says, hey, I have no more scores to give. That's the end of all the data I have for you. Or an example like this. Int total equals 0. So enter points earned or -1 to finish. So in this case, we're treating -1 as a very sort of special sort of user input that when they enter in -1, we're going to tell the program to quit. So we're going to cin points. And remember, it's an integer, so it can be negative. But we're going to cin points while points is not equal to -1, which is the sentinel. Take total plus equal points and then prompt again. So this program can keep going and going and going until the user enters the sentinel, -1. Let's check out an example on 267. All right, some integers. Game equals 1, points, and total equals 0. Enter points earned for each game in season, then -1 when done. Cout. Enter points for a game. Yeah, I guess I'll put a space there. Game, which we have initialized to 1 with our little prompt here. cin points, while points is not equal to, remember that exclamation point stands for not, while points is not equal to -1, our special sentinel character, take total plus equal points, which we remember, total equals total plus points. Same thing. Game plus plus, cout, enter points for game, followed by our prompt, cin points. This is not great in terms of code reusability. You can see we're kind of doing the same thing more than once here. It would be nice if we didn't have to repeat ourselves with this piece, where we're prompting, we're cinning, and then looping again. So we ideally, and there is a better way to do this, which I believe we'll see here coming up next. Ideally, we'd only want to do this once, the prompt and the cin, but we only have the while loop right now, so we're kind of using what we know. Let me collapse all these. 5.9, set a startup. I'm getting sloppy with my return 0. And my total. I better display that. Let's see out. Team has earned total points so far. Yeah, we'll return 0 for good measure. Now we can run it, match the input of the exercise. So let's do 1, 3, 0, 3. It's going to keep going until we say quit, which is -1. Team has earned 7 points so far. You can see here program output with different example input shown in bold. So enter points for game. If they just hit -1 right away, they're just going to say the team has earned 0 points so far. Just to show you that it works with no valid points entered. Okay, so that brings us to the do while. The do while is a post-test loop, meaning the condition is evaluated after the loop executes. Couple notes on the do. So we start with the keyword do, followed by one or more statements, just like we had in the body of our while loop. Then, after our statements, after the closing curly, we have our while keyword, followed by our open close parens in the condition. They pointed it out pretty explicitly here. With the do while, we have to have the semicolon after our condition. Okay, so with the while loop, it was not a guarantee that my statements in my loop body would execute. If the while condition was false, the statements would be skipped over entirely. With the do while, it's guaranteed that your statements are going to be executed at least one time. This would have been a better example for a do while, because we know we want to prompt the user and accept input one time at least. Maybe it's only one time, but at least one time. So the do while would have worked better here. Driftly in the wild, in the real world, I don't see do whiles all that much. And the dirty little secret is that you can do anything with any of these loops. It's just certain ones tend to lend themselves better to certain situations. Okay, here's the flow of control, the flow chart. So when we come into the do while, we're running the statements first. Then we're checking the condition. If the condition is false, move on. If it's true, go back up and do the statements. So here again, we're guaranteeing that the statements will be executed at least once. Some notes, the loop body always executes at least once. Execution continues as long as the condition is true, just like our while loop, just like our if statement. The loop is exited when the condition becomes false. Again, the parens are not required, but you must have the semicolon after the condition at the end of the do while. Let's get our hands dirty with the do while. 270. Listing 510. int score 1, score 2, score 3. Double average, good old average program, char again. All right, here's the syntax. So do. And what I like to do with a do while loop, the few times that I do use it, I write the do, I write the opening closing curlies, and then immediately I'll come down to the closing curly and finish up with my while and my condition, and very importantly, my semicolon right away. So what's our condition? While, again, which is a char, is equal to a capital Y, or, again, is equal to a lowercase y, run this loop. What's the loop body? Let's see out. Enter 3 scores for me to average. Cin score 1, score 2 with this horrible cin chained syntax. I guess it's okay. I just don't like it. Average equals, let's crunch some numbers. Score 1 plus score 2 plus score 3. Doing fractional division divided by 3.0 with our parens. If we excluded the parens, this code would have taken score 3 divided by 3.0 and then added score 1 and score 2. Here we need to take the total sum per the definition of average and divide it by the fraction 3.0 to force fractional division. Okay, see out. Average is average. Okay, then if our user loves this program so much, we can print out, do you want to average another set? Y/n. You used to see this sort of prompting on like really old mainframe systems where users interacted with the computer via a text terminal. You would see this Y/n. And then we'll cin again. So a couple notes here. Notice we're not explicitly checking for the no condition. All we're checking for is the yes condition, and then we can assume if they enter anything else, if it's an N, if it's an A, anything else, we'll exit the do while loop. Alrighty, enter 3 scores. So we're going to chain our inputs together here. So 80, 90, and 70. The average is 80. Good. Do you want to average another set? Sure. 60, 75, 88. The average is 74 and a third. Do you want to average another set? How about O? It would have also exited if I had put in N, of course. Check this out. Textbook. Right after program, we're listing 5-10. So the to upper function. Let's take a closer look at the line containing the do while loop test expression. So they have the logical OR operator, so double vertical pipe, to check for capital or lowercase y. However, you can use something like this. Ignoring the special case. You can use a to upper function. So letter 2 equals to upper A. See out letter 2 displays the capital A. Same thing with B. Same thing with C. So this is a way to like convert all lowercase letters to uppercase, or if they're already uppercase, they'll just stay uppercase. Okay. Do while and many driven programs. So do whiles can be used to bring the user back to the menu to make another choice, Oh, and here's the notes on toUpper. So to simplify the processing of input, use toUpper or toLower functions, allowing you to check input regardless of the case of the input. And we need to include another library to use it. Here's an example. So we're going to do some stuff. We're going to prompt for another choice, while the choice is equal to uppercase or lowercase y, or you could write it like this. So if you wanted to just deal with upper, so you could say if toUpper choice is equal to uppercase y, or you could do this, if toLower choice is lowercase y. Either works just fine. Let's take a look at this program. I don't think we'll do it per se, but 272. Notice IOmanip. Yeah, so here we're doing a kind of a rewrite of one of the programs we looked at a chapter or two ago. So we've got our adult rates, our child rates, and our senior rates. Here we're printing out a menu. So notice that the menu is now displayed right away after the do. So we're going to enter into our do loop, display our menu, prompt for a choice. We're going to validate that choice. So here we have actually a nested loop. That was one of the topics for today. We haven't hit a slide on it yet, but it is an example of a nested loop. We're inside of a do loop. Now we enter into a while loop. And we're using the while loop to validate the menu selection, which is 1, 2, 3, or 4. So while choice is less than 1 or greater than 4, we're going to keep prompting for a valid input 1, 2, 3, or 4. Process the user's choice. So if the choice is not equal to 4, which we know from our menu is going to quit the program. So after this gate, keep using that term, makes sense to me. I hope it makes sense to you. This is like a gate allowing the user to proceed through after they've entered valid input. If we know that choice is now between 1 and 4 inclusive, and it's not equal to 4, it's one of these other three. It's going to be 1, 2, or 3, and then we enter into a switch here. So this is getting pretty deeply nested. So we've got a do, then we've got a nested while, then we have an if inside of our do, and then we have a switch nested inside of that. So you can see that the indentation is getting quite deep here. There's nothing necessarily wrong with that. Some programming purists will claim that you should never go more than a certain number of indents deep. Otherwise, there's some optimization that can be done. I'm not one of those people. For me, this is just fine. So again, we've got a switch inside of our if statement. So we're switching on choice. So if choice is 1, run this calculation. If choice is 2, run this. Choice 3, run this. Then we'll display the total charges. And now, all the way up here, so this closing curly matches up with my do. This is another reason why I like to write my while condition right after I write my do statement. So while choice is not equal to 4. Now my personal favorite loop, the for loop. Take a drink. Okay, why do I like the for loop? Because it's compact and it's concise and very convenient. It's a pretest loop that executes 0 or more times, so it's useful for a counter-controlled loop. Here's the syntax. And I know when I was starting to learn programming, the for loop syntax was somewhat confusing to me because it looks nothing like a do or a while loop, or even really an if statement. But it does combine the parts of the do and the while loop into a compact syntax. And here's what it looks like. So keyword for, open paren, closing paren. So we have some initialization code. Then we've got our test. You can also call this your condition. And then we're going to update some variable. Your statements still go inside the opening and closing curly. Notice the semicolons. There are 2 of them inside of the parens for our for loop. One goes after our initialization code. One goes after the test, or in other words, the condition. Semicolons do not go here at the end of the closing paren or after the closing curly. Sometimes these kind of formal definitions of syntax might look a little confusing. Here's an example. For loop mechanics. Sounds like physics or something. So step 1, perform the initialization. So all the parts and pieces of our other loops are still here. They're just combined. We have our count variable. Here's our initialization. We're initializing it to 1. Here's our condition. Notice the semicolon there. Condition is while count is less than or equal to 5, and I'm still using while terminology. While count is less than or equal to 5, count plus plus. Add 1 to it. So step 1 is run once. We do the initialization once. Then we check our condition. Yes, 1 is less than or equal to 5. So we run the for loop statements, the body of the for loop. Then we increment count by 1. Run the condition. Condition's false. Print, increment count by 1. So this keeps us from having to increment count basically inside the body of the loop. It's included up here. Flow of control. Yeah, I guess. So you've got your initialization code. Before you go into your test, before you go into your decision making, you run the initialization, then you hit your test. If your test fails, just like always, we move on. If your test succeeds, if it's true, run your statements, run your update code, come back to the condition. Another example. Int sum equals 0 and num, int num. For num equals 1, num is less than or equal to 10, num plus plus. Notice the semicolons. Here's our initialization. Here's our conditional, semicolon, num plus plus, no semicolon there. Here's the body of the for loop, which they've omitted the curly braces, which is perfectly valid C++ syntax. So we run the initialization once. Then we see is 1 less than or equal to 10? Yes, it is. Run the body of the for loop. Then increment by 1. Is 2 less than or equal to 10? Yes, it is. Run the body of the for loop. Then increment by 1. Rinse and repeat until num becomes strictly greater than 10. And in this case, we've been keeping a running total or a running sum. We print that out at the end. And we move on in the program. Let's get some hands-on with the for loop, because they can feel kind of strange to write if you're not used to writing them. What page do we got here? 277. Listing 512. Pretty basic syntax example here. So we've got an int num cout number square cout some hyphens 4. Okay, keyword 4. Opening, closing, paren, our initialization. Num equals 1, semicolon. Condition, while num is less than or equal to 5, semicolon, update, num plus plus. Let's drop in our curlies here. Let's see out a set width of 4, num, set width 7, run a calculation, num times num, and line. Okay, number 12. No user input here, just running a basic for loop example. There you go. Calculating the squares again. Let me show you this. Here's a sneaky little, even more compact way of writing a for loop. You can get rid of this int num up here. You can just drop that right down here. You can just make it all on a single line. Don't need to declare that variable externally outside of the for loop. You can do it right in there. some notes. So if the test is false the first time it's evaluated, the body of the loop will never be executed. So this is similar to the while loop. So it's possible that the for loop statement body will never run. The update expression can increment or decrement by any amount. Variables used in initialization should not be modified in the body of the loop. What that means is that I should not be monkeying around with num inside of the loop body. I can. It's not always a bad thing to do. There are certain times I've done this actually in the wild when it is necessary to update your counter variable inside of the for loop body, but generally it's not needed. That's the whole point of the for loop, is that you're doing that up here. So we'll be explicit and comment that out. Done in for loop body. For loop modifications, so you can define variables for initialization. Define variables in the initialization code. I just showed you that. So right here. So we put the int sum equals 0. Oh, you can do, I didn't even know you could do this. And int num equals 1. You can chain together variable declarations and initializations inside of your for loop initialization section. So I showed you int sum equals 0. I was like, why is this a comma, not a semicolon? Because they snuck in another declaration and initialization. Cool. Learned something new. Here's our condition. Here's our update. I've never seen this, needless to say, in the wild, but I guess it's valid. Not recommended. Yes, let me take a drink and take a look at this. Definitely not recommended. You can omit the initialization if you've already done it somewhere else. If you're doing stuff like this, then you probably don't need to be using a for loop. They've just skipped the initialization, put the old semicolon there, and moved on with their lives. You can omit the update if done in the loop body. So here's the initialization. Here's the comparison. Your expression, then they've semicoloned and they've never run their update section. It's done right here though. Terrible. You can omit the loop body if all the work is done in the loop header. I have seen that and I hate it. Meaning they're doing this kind of calculation probably somewhere like over here after the semicolon. Don't do it. Not recommended. Moving on. Okay, deciding which loop to use. So a while loop is a pretest. Loop body may not be executed at all. Almost always, at least in the programs, examples I've seen, your main game loop in your game programming projects make use of the while loop. And they say while true, do stuff. And don't break out of the loop until usually the player tells it the program to do so. Do while is the post test. Loop will always be executed at least once. And if you like a compact form of syntax with a pretest loop, use your good old for loop. Nested loops. A loop inside of a loop. Okay? These are they're used a lot if you're dealing with like a two-dimensional structure of data, or in other words, rows and columns. So if you're like looping through an Excel spreadsheet or something where the spreadsheet has sets of rows and columns, your nested loop can come in handy. Let's take a look at one of these on page 283. Example 513. Oops. Another test score averager. Okay, int num students num tests double average, cout how many students, question mark, prompt, cin num students. I'm getting errors. Why is that? Because I forgot to use the standard namespace. Another little prompt here. Okay, here's a nested for loop. Good practice with for loop here. So for int snum equals 1. Snum is less than or equal to num students snum plus plus. Double total equals 0.0. For int test equals 1. Test is less than or equal to num tests test plus plus. Int score cout. Enter enter score for test. Here we go. For student. One second. Let me drop this down on a new line. There we go. Enter score for test for student snum is what I wanted there. Followed by our prompt cin score. Total plus equals score. So what we're doing here, just to give you some intuition about what all this is getting at, we have a list of students and we have a list of scores per student. So each student has a list of scores. That kind of sounds like a two-dimensional array of data. So one loop is looping through the number of students. The inner loop is looping through the number of tests for that particular student. So we've got our total for any given student here. Say average equals total divided by num tests. Cout average for student snum is and we're good. Let's activate this project. Okay, how many students? 2. How many test scores did each student have? We'll say 3, matching the book. 84, score 1. 79, score 2 for student 1. And then 97, score 3 for student 1. Average is 86.66, or 2/3. All right, now we'll do 92. We'll do 88, 94. Average is 91 1/3. Very good. So for when we enter the number of students, again, that's our outer loop. So 2 is going to be our terminating condition here. Once snum becomes greater than 2, then this outer loop is going to terminate. But for each inner loop, for each student, that condition is 3. Num tests was 3. So we're running 3 inner loops per outer loop. If you multiply that together, here's a little computer science math for you. Computer science programs at four-year colleges and universities spend a lot of time thinking about this kind of thing. How many times nested loops iterate or execute, for example. So if we had 2 students with 3 tests each, 2 times 3, crunch the numbers. We had 6 statements. Okay, the inner loop goes through all of its iterations for each iteration of the outer loop, kind of what I just said. The inner loop completes its iterations faster than the outer. Total number of iterations for the inner is the product of the number of iterations of the 2 loops. Previous example, inner loop iterates 9 times in total. How do you break out of a loop if you want to get out of it early? So you can use the break statement to terminate the execution of the loop iteration. Use sparingly, if at all. Makes code harder to understand, definitely is true, though sometimes you have to use it, like in the case of game programming. So if the user says quit the game, and you're inside of your infinite main game loop, the break statement becomes very handy. When used in an inner loop, break terminates that loop only and returns to the outer loop. So if we put a break statement inside of this inner for, it would break out of the inner for, but your outer for would still execute, would still be going. Let's take a look at just the code for this one, 5-14. Here we go. Program is supposed to find the square root of 5 numbers entered by the user, but if a negative number is entered, an error message is displayed and a break statement is used to stop the loop entirely. So we're going to see how we can bust out of this loop early if we need to. All right, double number. So enter 5 positive numbers separated by spaces. I'll find the square roots. So here we go. So prompting for input. If the number is greater than or equal to 0, the square of the number is, here's a new one. I don't think we've seen this built-in math function yet. So we can use sqrt to quickly find the square root of a number. And we need to include cmath to do that. So if it is greater than or equal to 0.0, we can do the normal thing. Otherwise, the else case here is kind of the error case. If that happens, we print out an error message, we break, and that's the end of that for loop. So I'm not going to take you through typing that by hand, but you can see what happens here. Enter 5 positive numbers separated by spaces, and I will find their square roots. Here are the numbers until they get to -17. Square root of 2 is that, 15 is that. Then they encounter the negative number. Cannot find the square root of a negative number. Program is terminating. So you kind of can find the square root of a negative number, right, with imaginary numbers, but way outside of the scope of this class. Okay. So continue. You can use the continue statement to go to the end of the loop and prepare for the next iteration. So while and do while loops go to the test expression and repeat the loop if the test is true. For loop goes to the update step, then the test, and repeats the loop if the test condition is true. Also, notice how they say use the continue statement sparingly, like break. It can make the program logic hard to understand. Shifting gears a little bit to a very exciting topic, and I'm only kind of being sarcastic, using files for data storage. Like I said earlier, it's kind of a seemingly random topic to include in a chapter on looping. But if we think about it, what we're getting at here is we want to use an external file to read in data to our C++ programs. So we can use a file, or output, I should say, read in data to our programs or output data to the text file. So you can use a file instead of the computer screen for program output. Files are stored on secondary storage media such as a hard drive, thumb drive, etc. And you can use files to permanently store the result of your program's execution. It's not just stored in memory anymore, so it's not lost when the program shuts down or the computer restarts. If you're using files for data storage, then that data persists even after a computer restart. A couple file types. Maybe you guys are familiar with these already. A text file contains information encoded as text, like ASCII characters. Letters, digits, punctuation can be viewed in a text editor like Notepad or Notepad++. So a binary file contains binary, ones and zeros, information that has not been encoded as text, cannot be viewed with the text editor. Actually, that's kind of a lie. It can be viewed. You're just not going to know what the heck you're looking at. So file access, ways to use the data in a file. So sequential access, meaning you start reading in the first piece of data, then you read the second piece, then the last piece, and so on until you reach the end of the file. You can also get random or direct access, meaning you can retrieve any piece of data directly without the need to retrieve any preceding data items. So you go to the data you need, retrieve it, and that's it. It's a lot faster than sequential access, which you have to go through the entire file to get what you need. Random allows you to go right there and grab it. So what do we need to use files? So there's a little bit of ceremony that's needed to access files from a C++ program. So we have the if stream and the OF stream, so input file stream or output file stream in your header files. So they define a file stream object, is what it's called. So we'd use if stream for reading data from a file. And it looks like this, where the if stream is basically like your data type, and then your variable name, your object name, in file. Same thing with output file stream. This is like your data type. This is like the name of your variable. So we have our header files now. Now we want to open the file. So we have to have a file to open that basically sits inside of the same directory as our program that's running, so we can access it. So for example, inventory.dat or report.txt, these are both flat text files. It doesn't, truth be told, the file extension doesn't really matter. It's the contents of the file that matters. So if you have a file called inventory.dat and it just contains just raw text, ASCII characters, you can open that file using Notepad or Notepad++ to view it, edit it, whatever you need to do. File name may include drive or path info, so if this file is actually located inside of a subfolder or a subfolder within a subfolder, you can include that information in the path here. And you must include the file extension. And it must exist for open to work. So obviously, if you don't have the file on your hard drive, you cannot open it. So you create a file stream object, and it can be accomplished in a single statement like this. So you can combine the declaration and initialization. To use the file then, so if we want to like print data to a file, it's sort of like cout. We still use these angle brackets, only now instead of cout, we're saying out file, angle bracket, followed by the text we want to put inside of that output file. For your in file, it's kind of like cin. So we flip the angle brackets, we say in file instead of cin, and then what data do we want to put into that input file stream. So just think of cout and cin. Same thing, only instead of those keywords, we're using an input file stream and an output file stream. And it's really important when you're done to close the file. So you say input file stream.close or output file stream.close. Don't wait for the operating system to close files at the program's end because of these reasons. There may be buffered output data waiting to be sent to the file that could be lost. Other files or other programs on your hard drive may be wanting to use that file, and maybe they can't if your program thinks it's still using that file. So close them up when you're done. Stay nice and tidy. Let's take a look at a few examples of file I/O. Page 294. Cool. Now let me create this. Console app. What was this? 515. Now, working with File I/O inside of Visual Studio can get a little bit squirrely, and I'll explain why in a minute. First, let's include, we got IOStream. Let's include FStream. That should get us OFStream and IFStream in one handy little include. So let's using namespace std. Now don't let this part freak you out. Instead of saying like int num or char grade, we're saying here's a thing called output file stream, OFStream, called output file. Notice the syntax highlighting is slightly different. That's because this isn't just an int or a char or a double. It's an output file stream object. We can do more with it than we can with just your standard int or double or float, as you'll see here soon. So let's do this. Let's open the output file. Output file dot open. You can see my code completion there. We'll call it demo file.txt. Cout. Notice cout, not output file stream angle bracket. So we're just printing the standard output here or the command prompt. Now writing data to the file. Output file, angle bracket, I guess composer names, Bach, new line, so new line definitely will work here. Beethoven. Mozart. Schubert. Schubert. Now we're going to be nice and tidy and output file dot close. Cout done. Now, think about it. Is this going to work when I run it? Give it a thought while I make this my active project. Set a startup, try to run it. Now writing the file, done. Okay, that's interesting. The problem is, where is it? We obviously didn't create a demo file.txt. So it like magically created this file to output to? Yeah, I guess so. I guess that's how output file.open works. If it can't find that file, it goes ahead and creates it. So let's see. It doesn't exist, it looks like, in my project folder structure here. Let's see if we can navigate to our computer's hard drive. I'm just going to right click on that project file and then open folder in File Explorer. There it is. It created that file for me because it didn't exist and it needed to write it somewhere. If it had existed, we would just open it and write to it. But it didn't exist, so it created it. That's just a property of how OFStream works. And certainly if we open this, here's my fancy Notepad++. Here's my composers list. Now what happens if I close this, rerun it, did it again? Let's open that, maybe just in Notepad. Notice how it just rewrote over the top of it. It didn't like append to that file. It just rewrites what's currently in it. But we got it. Cool. That's actually kind of useful. Now somebody could say, hey, can you write me a program that does a bunch of math and puts the result of that math in an external file? How about another one? 295. Let's check that out. I think this is the opposite. Oh, not quite. We're going to write user input to a file. That's a good example. Let's do it. What I meant by using Visual Studio and File I/O getting squirrely is that we don't really know. We didn't have a good intuition on where that output file.txt needed to be stored, or where we could read it from, or where it got created in the end within our file system. So we did some detective work and found out, but it wasn't exactly clear to us right away where that thing was going to exist. Luckily, Visual Studio makes it fairly easy to figure that out. So EX516. Alrighty. What do we got for includes? IOStream, FStream, and include string. Useful when dealing with ASCII files. All right, let's play with some file I/O. So here we're going to create an OF stream. Output file, string name, output file.open, about friends.txt. Now, good programming practice, as soon as I open that thing, I'm going to go ahead and say output file.close to make sure I don't forget it. I'll see out names have been saved, and I'll return. Now, all the guts of the program goes in between where I'm opening and closing the file. Okay, it's open. I can write to it now, so we'll see out enter names of 3 friends. 4. Int count equals 1. Count is less than or equal to 3. Count plus plus. Good old for loop. See out friend number count. Prompt for a name. Cin the name. So we're still using cin here. We're still prompting the user for input from the command line, but now as soon as we get the name, we're going to say output file, angle bracket, name, angle bracket, end line. Let's see what the textbook uses. So they're saying like Joe, Chris, Jerry. Names have been saved. And if you notice from the code, it's writing to that file after each time I input. It's not like it's batching all of that information up and writing it all at the end. It's writing it to the file one at a time after I enter each name. Where, oh, 516, of course. Yes. Right here, friends.txt. Check it out in Notepad, Joe, Chris, and Jerry. Excellent. Let's see what 197 has in store. Sorry, 297. Yes, reading data from a file. Okay. So now we're going the other way. We've been writing data to a file. Let's see if we can read data from a file. $517. I'm losing it. There. It's getting late. We'll finish strong here. All right. I should mention, now that we know how to do file I/O, there may be occasions in your assignments that refer to external files like TXT files or DAT files. Those files are available, first of all, in the student resources from your textbook. Also, just for ease of access for all of us, I've gone ahead and uploaded the textbook listing. So the sample code that we've been going through together, I've uploaded to chapter source code listing. So here you're going to find all the source code files, CPP files, header files, external files like we're working with here. You'll find those in the relative folders. But for your assignments, whenever they refer to an external file, you'll have to go to the textbook website, locate the student resources, and download them there. If you have trouble with that, let me know. I can help you out, hook you up. But just a fair warning, that is coming. So we've created an OF stream. In previous examples, let's create an IF stream, an input file stream called input file. That's better. String name, so we'll say input file dot open. What file are we going to open? Friends.txt. We'll see out, here are your friends. For int count equals 1. Count is less than or equal to 3. We happen to know that there's 3 names written in that file. Count plus plus. Here's where the action is. How do we actually get something out of that file? So input file. Like so. Let's close it up. Return 0. Okay, a couple things. They're assuming we have friends.txt in this folder. We don't. That was in the previous project. But this is 517. Let me activate it. Learning on the fly here. Troubleshooting on the fly. Let's see what it does. Okay, nothing. That's what I would expect. Let's open up the file in Explorer here. 517. There is no file. Called friends.txt. Let's maybe copy the old one from the previous project over to here. There we go. It's nice that it didn't crash when it couldn't find the file. It sort of failed gracefully, I would say. But we did definitely read in data from an external file. Very, very useful. Okay, user specified file name. So taking it a step further, we're almost to the end here. So a program can prompt the user to enter the names of input or output files. That makes a program more versatile. So what this is getting at is you could have your user name the file. Instead of friends.txt, they could name it myfriends.dat or whatever they wanted to. Kevin.text. C++ is great.dat. Prompt the user for that, and then have them basically have them name their own files. All right, let's take a look at this slide. Using the angle bracket operator to test for the end of file, or more commonly known as EOF, of an input file. So the stream extraction operator, which we've been calling angle bracket, returns true or false, indicating if a read is successful. Can be tested to find the end of a file, since if the read fails, that means there's no more data. Here's a common pattern, what it might look like. While in file, stream extraction operator, score, sum plus equals score. While this is true, just keep adding data to sum. When this fails, when this becomes false, that basically means implicitly that there's no more data to read. Let's check out this hands-on. We'll just take a look at it. Yeah, it's a big one. So the program reads and sums numeric values stored in a file. So we have iostream string and fstream. Input file, so file name, looks like that's going to be defined by the user. Prompt the user to enter the data file name, open it up, loop through it, loop until the EOF is reached, and then sum total plus equals values, or value. Close it up. Okay, so we're just looping through. There's not like a sentinel. I guess you could consider the EOF as the sentinel, but it's very, very implicit. It's not like we're checking for a specific string or integer like a -1 or a -999 or an N or any kind of special character. The EOF is like built into the file itself. So let's talk about some file open errors. An error will occur if an attempt to open a file for input fails if the file doesn't exist, the file name is misspelled, the file exists but it's in a different place. Cool. Almost at 2 hours there. Really trying to keep them to 2 hours or less. So let's take a look at a few more programs. Okay, so creating good test data. When testing a program, the quality of the test data is more important than the quantity. So one test that tests all aspects of your program is more important than many tests that only test a small fraction of it. Test data should show how different parts of the program execute and ideally should test or exercise every single line and part of your code. Test data should evaluate how the program handles normal data, data that is at the limits of the valid range, and invalid data. I will tell you that most errors occur at this point. Data that is at the limits of the valid range. Normal data is usually fine. Invalid data is usually fine. Where you run into trouble is usually sort of data at the fringes of what your program knows how to process. Let's see, I wanted to go to tying it all together. Almost there. 311, I guess I can type that. Come on. Okay, we can try this. So what this is going to do, it says demonstrates Windows functions to print colored text, displays hello world in 16 different colors. Kind of a silly, fun example, but it demonstrates this guy. Let's take a look at it. So this is example 523. New project. All right, include a new thing. This is outside of the chapter. This is just, again, something fun that they give to us at the end of the chapter to kind of wrap things up. So include windows.h. Huh? We've never seen that before. Using namespace std. All right, create a handle to the computer screen. Neat. Sounds kind of interesting. So here's a data type called handle, a variable called screen equals a call to just bear with me on this one. Get std handle std output underscore handle write 16 lines in 16 different colors. Have fun. For int color equals 0, color is less than 16, color plus plus. Set console text attribute. This is like cout on steroids. Set console screen text attribute of the screen that we just created to the color that we want to use. Here's a good old cout. Hello world. Sleep. Can delay the execution of our program for, looks like 4 seconds. It's going to give us a nice pause. And then finally, after that for loop executes, go back to screen, set it to color 7, whatever that is. I guess probably white. Semicolon, 523. Actually a little nervous. Oh, there it is. I haven't tested this one. I'm guessing the first line of text is hello world in black, if you can't see. A lot of new stuff going on here that we don't necessarily need to talk about for the chapter, but it's cool. Sleep is how you delay execution of your programs. Like I said, the get std handle gets you a handle to the computer screen. It's how you can interact with the screen and the standard output in a lot more sort of detail. Get a lot more access to built-in functions. Way beyond the simple command line output we've been working with. There's another fun example if you guys want to do it on your own. 524 prints to ABCs in red, green, and yellow. And it uses, oh dear. Abort. It uses a, let me go to the next page. Yeah, uses a for loop to go ahead and do that. So it's like, cout letter, yeah, plus plus, letter plus plus. Utilizing those ASCII codes behind the scenes and some basic math, adding 1 to the ASCII code to basically print out the ABCs. Same thing with the colors. Okay. A lot of good stuff in this chapter. Looping structures. Make sure you take a look at that for loop. The for loop is the one that trips up a lot of new students because the syntax is so different and so compact compared to the while loop or the do while loop. As always, check out your assignment for this chapter. Chapter 5. Quite a few of them here, but I don't think any of them are going to be too wildly difficult for you. Again, if any of the questions ask for or reference external files, go to the textbook website. All that stuff's available for you there. Till next time, thank you very much.